Hi everybody, it's Dr. Jensen with CCJ3701 Research Methods in Criminology. So I turned my video off just because we're going to be in SPSS later on in the lecture, and you don't need to see my ugly mug, do you? So anyway, if you miss me, let me know, but I turned me off so that way you can see more of the screen, because I'm going to be switching from the slides to SPSS so we can do some more practice. So we're back in bivariate statistics. We already covered ANOVAs and t-tests. We need to cover correlation. So what is Pearson's R? It's correlation, okay? So in crosstabs, what we did last week, you measured association between two variables. They were both categories of some shape or form, right? Like gender and rank, or religion and race, or stuff like that, okay? In correlations, you're measuring the association between two interval variables. They both have to be quantities, like income and years employed, okay? So generally speaking, we might assume that your income tends to go up as the years employed goes up, right? We think that you should be getting more money the more experience you put into your job. That may or may not be the case, right? So that'd be kind of a fun one to test. But those are both quantities. We have income in dollars, we have years in years, right? You know, we have time, okay? So you have to have two variables that are interval, that you can do quantities or numbers within, okay? Correlations are used to represent association. We call it Pearson's correlation coefficient. Again, correlation, literally the word co-relate, okay, where these two things co-relate together, measures the strength of the linear relationship between two variables, okay? So we're going to get into an example in SPSS right now, okay? So you can jump in and play along if you'd like. I am in SPSS, so if you need to pause the video to launch SPSS, you can. Go to apps.ufl.edu, launch the SPSS 24 Citrix viewer. You'll find the data. This is called the Law Enforcement Management Data 2007. You'll find this data in the R drive, right? So I already loaded it in there. If you open the file, you'll actually find the file in the Common Files R drive, okay? And then you go, of course, to your courses, the CCJ3701, then the data folder, you'll find the file in there, okay? So go ahead and open the data, launch SPSS, pause the video, resume when ready. Okay, so if you want to just kind of follow along and watch the screen, you can, and maybe it's easier to do that, and that's fine. So we're going to go run a correlation, okay? So the one we're going to run is actually a relationship we're going to test between how many employees an agency has and what the chief's salary is, the salary of the chief of that law enforcement department. This is a fun data set. Some of you might even be interested in looking at some of this stuff for your research project. There's some good data in here, okay? So again, we never analyze what we don't know, so we need to go find these two variables and get to know them. Let me just move this over slightly so you can see better. The first variable we're going to use to test this question is called sworn auth emp, okay, meaning sworn authorized employees, okay? So we actually have different categories of employees here. So you have some people with arrest powers, some people without, people who are full-time and part-time. We think when you have more sworn personnel, full-time personnel, you probably have a chief that gets a larger salary, but we don't know. We're going to test it and run a correlation, see if that's true. So let's actually highlight sworn auth emp, okay, row number 9. Run descriptive statistics on it because we never analyze what we don't know. So this is just descriptives on this interval variable. It's a quantity, so they don't usually give you frequencies when you right-click like that. Here's the mean. So the average number of full-time employees was 172.6 employees. The median was 40. The minimum was 0. Maximum was 35,000 employees. Holy cow, that's a big agency. But let's actually look at the frequency. Remember, you can always go in the Analyze menu from your output. Okay, so if you go Analyze, Descriptives, Frequencies, we're going to go put the variable I was using back and get sworn auth emp. That's one of the top variables in the list. Again, you may have to right-click and change from the label to the name so you can find sworn auth emp. Put it in the queue, click OK. This is just the frequency that shows you the number from 0 to 38,000 and how many agencies had that number of full-time sworn personnel with arrest powers. Okay, and so on the left is the number of employees they had, and on the right is how many agencies said they had that many employees. Okay, so this is a cool data set. It's got many different law enforcement agencies of all sizes in here. It's really, really cool. And mostly chief executives took the survey to get the data. So now we've gotten to know it. We can see what we have to work with here. We have some good data. We need to find our other variable, which is the chief's salary. Okay, we're all about to get really depressed. So the chief's salary information is a little bit lower. You scroll down just a little bit in the data, and you'll see salary kind of on row 94. Okay, right in there. We want to use the next row. It says chief max. So there's a chief minimum salary and a maximum salary. We want to use the maximum one. We want to get nice and depressed about how much money we don't get. Okay, so let's run descriptive statistics on that one. And here we go. Whoops, my output jumped around the screen a little bit. So we have the minimum of $12,000, that poor guy, and the maximum of $740,000. It pays to be a chief. Okay, and then the average was actually $94,000, 314. Okay, so that is the average salary for chiefs of law enforcement jurisdictions. Okay, so we've gotten to know our data. Let's run the correlation. So again, you can run any statistic from directly the output menu. Let's go to Analyze and Correlate. That's where we find the function. We're going to run a bivariate, so select bivariate. And then all you have to do is you just pop those two variables in the queue. That's it. You don't have to do anything fancy. Okay, so I'll put them back just so you can find them with me. Okay, so you can, again, you may want to flip from the labels to the names, and we need to find sworn auth env, and they have little rulers by them. They are quantities. We also need to find the chief max. You can even start typing the word chief, like CH, and it'll find the chief max. Okay, once you have both those variables in there, click Options. I like to ask for some extra stuff with mine. So select the means and standard deviations, because that gives us more information about what we find. You could ask for some of this other stuff, but it's not really necessary. Click Continue. Make sure your Pearson correlation coefficient is checked. And also check your two-tailed test of significance. This other thing you have to worry about, that just says, do you want to see the significance obviously or not? Do you want to flag them? I just leave it checked because it's helpful. Once you have all that set up, click OK. And first we get the descriptives, okay? So right here we have the average or the mean, which we saw before. And we saw the average mean for the second variable. So 172 average number of employees, $94,000 average salary. Let's check out the correlation though, okay? So the correlation, you want your eyes to kind of go in these two corners, okay, where it says Pearson correlation, it has this 0.263. Okay, these two corners kind of repeat themselves, okay? So this is the information we want. The Pearson correlation coefficient, or R, is 0.263. That means something to us. We'll tell you what it means in a minute. We also get a significance level of 0.000. That's a good sign. That means we're highly statistically significant. And then here in the bottom is how many cases we could run in this analysis, 2,598. That's it. So let's take this piece of information and do some interpreting. Okay? So here was our output we got. Again, focus your eyes in the bottom right of the correlation. The way we interpret Pearson's correlation coefficient is here. Okay, so there's just a little chart. It's always interpreted the same way. The correlation coefficient, or R, is 0 between 0 and 1, 1 between -1 and 0, or -1. So it doesn't matter what the actual value is. We just have to see where it fits in to these values. So if the R value is a perfect 0, the two variables do not vary together at all. They got nothing to do with each other. You can safely say these two things are not correlated. They do not correlate. They do not predict each other. Okay, and case closed, you're done. The next one says if it's between 0 and 1, it's positive. The two variables tend to increase or decrease together. They both go in the same direction. Okay, which we're going to use that one in a minute. A perfect one means these two things are perfectly correlated. They move in synchronous fashion exactly the same way. Again, they both tend to increase or decrease together. If your R value is between -1 and 0, one variable increases as the other decreases, okay, which means as this goes up, this goes down, or vice versa. A -1 is what we call perfect negative or inverse correlation. Again, as one goes up, the other goes down. Okay, so that describes how the relationships work with R. So going back to our example, 0.263 means what? It's that second row. R is between 0 and 1, so it's a positive number. It's not big enough to be a 1, but it is larger than 0. So we can say these two things tend to increase together. If it was negative, that means they tend to decrease together, okay? But it is positive, so basically as the number of employees for an agency increases, so does the chief's salary. It also increases, which makes sense, right? Because you have more personnel, it's a larger agency requiring more management and more skills, okay? So yeah, these two things are highly correlated and they both increase together. So that's how you do a correlation. It's pretty easy. But you have to have quantities. Both of these variables have to be interval or you can't run the test. Let's talk about a few other things. What correlations can and cannot do. They can show how variables correlate in this linear fashion, okay? But they cannot measure curved lines. Curvilinear relationships are what we call U-shaped relationships that tend to change direction over the course of the other variable. So here's an example. People who have very low anxiety, who are what we may call mentally sleepy, or people with very high anxiety, they're kind of edgy or jumpy, they will both perform poorly on a class exam. That's a U-shaped exam, okay? So it's people with two different predictors getting kind of the same outcome, and it changes direction from very low to very high. Here's another example. When people are married, their marital satisfaction tends to be very high and then dip and then go very low and then come back high again. So that also is a curved relationship. So if we said over time, how happy are you in your marriage? At the beginning of a marriage, you were in marital bliss, right? The honeymoon period, you feel great. And so your satisfaction, your happiness is very high. As time goes on, you get kind of used to each other. Maybe you start having children. You start to have more stress and other things working on your relationship. Your happiness goes down a little bit. And then once life changes and you get into the empty nest phase, the kiddos have left the house, or your work has become more stable, or life is much more predictable, your relationship tends to be better and it goes back up high again. So it goes from high to low to high. Okay, that's kind of a curvilinear relationship. Those kinds of relationships are famous in social science. And honestly, they're kind of tough to predict. You'll find out as you test those relationships, you'll get little errors in SPSS that say, yeah, you can't run a correlation on this. You can use other kinds of statistics to test those relationships, but you can't use a correlation. So you have to be on the lookout for that. And usually the research, the science, and the articles generated on those topics will tell you if those relationships are curvilinear or not. So you kind of have to keep an eye on the literature. Again, just by way of review, bivariates, we did t-tests, ANOVAs, and correlations, keeping in mind that the dependent variable has to be interval or ratio. For a t-test, it can be a nominal or an ordinal. Same thing for an ANOVA. The independent variable can be nominal or ordinal, can be a category. You're going to run the ANOVA if it has 3 or more categories. You're going to run the t-test if it has 2 or fewer categories. And then the interval ratio, independent, dependent, we use for the correlation. So remember back when in class I said you need to know how to do level of measurement. You need to know how different variables are measured, whether they're categories or quantities. This is why. So that way you know what to run. Okay? Again, just by way of review, significance levels. We saw one that was a 0.000, which is smaller than this 0.01 level. So we'd say it's highly statistically significant. We have a less than 1% chance of being wrong. But remember, this is how they work. And sometimes, tough for students to get used to. The chances I have of the relationship being true versus not being true. But I thought I'd put this slide up as a good final reminder of how to look at those significance levels, because we get significance levels with pretty much every statistical technique we run. We interpret those significance levels the same every time. All right, hope you enjoyed it. Thanks.